Hi, and welcome back to Psychology with me, Mr. Snyder. And today we're going to continue into Chapter 1 by talking about psychologists' research methods and ethics. So today we'll talk about the scientific method, various research methods, procedures that improve the validity of research, ethical standards with humans, non-humans, and the purpose of using non-humans in psychological research, non-humans being animals. So first off, the scientific method. You've probably had this since fourth grade. It is the system of gathering data in science so that bias and error are reduced. And you've probably learned, I don't know, 5 or 6 different scientific methods. I'm going to show you the one for psychology. And there are 5 steps. So first we have to, before we even come up with a hypothesis, we have to formulate our research question. We have to identify something in our surroundings for which we would like to have an explanation. Then we come up with a theory, which can turn into a hypothesis, a tentative explanation of a phenomenon that is based on those observations. And it's key to overcome confirmation bias by seeking out information that might contradict your hypotheses. So you can't just look for information that makes you correct. You also have to look for information that makes you incorrect, and that's confirmation bias, and we'll talk about that a little bit later. And then we conduct an experiment or a research method to test the hypothesis. Then we analyze our data and draw conclusions, and our measurements will either support our initial observations or they won't, and we'll need to go back to square one and think of another explanation. And it is related to the goal that we talked about in Module 1 of prediction that enables educated guesses about these future scenarios. And then lastly, you need to report your results because you need to let others know what you find so they can use it and build off of it. The lack of support for the experiment could be due to a poorly designed study or factors not under our control, but we may use the results or findings of the study to modify or control behavior. So that's why it's important to report your results in a psychology scientific journal, something to that extent. So the various research methods that we're going to describe, these are the descriptive methods. Number one is naturalistic observation. This would be watching animals or humans in their normal environment. So I like to use the zoo as an example. Watching animals at the zoo would not be in form of naturalistic observation. That is in our next method, which is laboratory observation. Watching humans at the zoo would be humans in their normal environment. The major advantage is you get a good picture, a realistic picture of their behavior. However, the disadvantages, one of them is the observer effect, and that is if you know you're being watched, you're going to behave differently. I'm sure you can attest to that in your studies. If the teacher's out of the room or if the teacher has their back turned and you're not being observed, you will behave differently. And so a way to overcome this is by participant observation, in which the observer becomes a participant in the group being observed. And people have done this with mental health studies. They've actually faked symptoms and gotten into a mental health institution where they became a patient to observe from the inside of what was going on. And that reduced the observer effect. Another one is the observer bias, in that observers only see, or they tend to see only what they expect to see, kind of a confirmation bias. But a solution to that is to have a blind observer, where people do not know what the research question is. They're just simply observing and describing what they see. And also having more than one observer can also facilitate comparison of those observations. Our next method is laboratory observation, where we watch humans or animals in a laboratory setting. We have a lot of control over the environment. We can make the environment whatever we want in the laboratory, and we can also use specialized equipment for it. But a disadvantage is that if we're in an artificial situation, we can't really say that that would be behavior that the subject would do in their natural environment. So it may be artificial behavior. So these two descriptive methods can lead to the formation of testable hypotheses. Another one is the case study, which is an in-depth study of great detail on one individual or group. We get a good amount of detail. Sometimes it's the only way to get certain kinds of information on things that are unethical, or so to speak, and I'll get into that in a second. And it's a good way to study rare conditions as well. But we can't really apply it to others because it's such a specialized situation. For example, Phineas Gage is probably the most famous case study. In the 19th century, he was a railroad worker who had a lead pipe kind of go through his brain, as you can see in this picture here, and it changed him. Obviously, his personality changed, his language changed. There were parts of the brain that were affected. He wasn't killed by it. He lived for another 10 years after it, but we'll talk about him some other time. Surveys are another research method, and when we want to know very personal things, we might distribute a survey or do a one-on-one verbal survey with somebody, and we would ask questions about a topic that's under study. Like I said, it could be an interview on the telephone, the internet, or with a written questionnaire. It's given to a representative sample, and a representative sample is the key term that is a randomly selected set of subjects from a larger population of subjects. So if my target population was Americans, I might give my survey to 100,000 Americans, and that would be my representative sample of the 315 million Americans that there are. Advantages to surveys are you get a large amount of data from a large number of people fairly easily, and you can study behaviors that people do that they don't really broadcast to society. So you can study these secret behaviors they do because they'll tell you about it if it's anonymous. The disadvantages are that it's hard to ensure that the representative sample is representative of the target population, or the results will not be meaningful. People are not always accurate, and people may give a socially correct answer in order to not be embarrassed or to not offend anyone, and that's called the courtesy bias. There was a study on how many times people brush their teeth, and if a lot of people said 3 times a day. This is back when it's 3 times a day. I think it's only 2 now. Methods have improved, but these people, we knew they were lying because not that much toothpaste was sold in the United States at the time. There would have had to have been like 3 times the amount of toothpaste. So a lot of those people were lying. Also, wording of survey questions and the order in which they can appear can influence the outcome of the survey. And so it's very, very important to get that correct. And then thinking critically about psychology can help us sort out real-world problems and evaluate claims that may be false, but people believe they are true. Now, how do we find relationships between our data? One way is called finding correlations, or relationships between the data, between 2 or more variables. And variables are anything that can change or variable. Vary. There you go. There's your root word. Finding relationships, basically the measurement of 2 variables goes into this formula and produces what we call a correlation coefficient, which represents 2 things: the direction of the relationship and the strength of the relationship. And here is the ranges. It's from -1 to +1. So the closer to -1 or +1, the stronger the relationship between the variables. The closer to 0 it is, so there's no correlation at 0. So 0.05 is not a good correlation. 0.3 is You get up to 0.4, 0.5, depending on the study, and you will have a very strong correlation. A perfect correlation is -1 or +1. And the negative and positive imply which direction it's going. A positive correlation, variables increase in the same direction. As one increases, the other increases. The more apples you eat, the healthier you are. That's a positive correlation. As one decreases, the other decreases. The less cigarettes you smoke, the less your chance of cancer is. And a negative correlation is variables that have an inverse relationship. As one increases, the other decreases. The more cheeseburgers you eat, the poorer health you will have. Just out of example. But the most important thing about correlations is that they don't prove that one causes the other. The closer you are to a hospital, the higher amount of sick people there will be. Does one cause the other? Does hospitals cause people to be sick? No. Do sick people cause a hospital? No. They don't relate that way. One does not cause the other. They are just related. They have a relationship. Here is a scatter plots showing, you can see a perfect positive correlation, a perfect negative correlation, modest correlations, and then no correlation would just be dots all over the place. And then we get to the last research method we have where we can determine cause and effect relationships in the scientific experiment. Now there are steps to the scientific experiment. We need to have our random selection of our sample from a certain population, whatever that target population might be. We need to have operational definitions of the variables of interest. For example, if our variable was aggression, aggression can mean a lot of different things to a lot of different people. We need to define what aggression is and what we are measuring as aggression in the study. And then this is probably review, but the independent variable is the variable that is being manipulated. So if we're studying the effect of music on test scores, one class gets to listen to music while taking a test, the other one doesn't. The only variable we're manipulating there is the music. That would be the independent variable. And then the dependent variable is what we are measuring. And so that would be the test scores at the end of that experiment. So did music help people perform better on the test? The groups. Basically, we take subjects or participants in an experiment and subject them to the independent variable, and we are trying to eliminate confounding variables, and those are variables that will interfere with each other and their possible effects on some other variable of interest. So confounding variables might be what kind of music we're listening to, or whether we're listening to it in earbuds or headphones, or what gender there is. Are there more boys than girls than in a class, or what the class average is of both of those. So those are confounding variables we need to worry about. Basically, to control that, we can have two groups, an experimental group and a control group. The experimental group is exposed to the independent variable. That would be, in our example, the class listening to music is the experimental group. The control group is the class not listening to music, and they get no treatment or some other kind of treatment that would have no effect, and we call that a placebo. In a medical experiment for a drug, the experimental group would get the drug and the control group would still get a pill, but it would be a sugar pill and not have any effect on them whatsoever. This is used to control for the possibility that other factors might be causing the effect that is being examined. We need a baseline in our control group. And it's important to randomly assign your people to either the experimental group or the control group, so that each subject has an equal chance of being in either group. This helps to control for confounding variables. Basically, some controlling for effects, it's studying people. We have biases about what we expect and what's going on in an experiment, and two of those are the placebo effect and the experimenter effect. The placebo effect is where the person who gets that sugar pill in the study, even though they're a part of the control group, they show improvement simply because they expected to, because they received some form of treatment. Human body is amazing. And so in those experiments, normally we look for results that are higher than what was achieved via just a sugar pill, because those people will show improvement as well. And then the experimenter effect is the tendency for experimenters' expectations to influence the results of the study. And so we can control for that by using a single blind or hopefully a double blind study. And what that means is the subjects in a single blind study don't know whether they're in the experimental group or the control group, but the experimenters do. And in a double-blind study, neither the experimenter nor the subjects know who is in which group, and that can reduce the experimenter effect. So in a single-blind study, if I'm interviewing a participant, I know which group he's in, and I can sort of influence the results. In a double-blind study, I don't know which group he's in. There's a sheet of paper somewhere that lists who is in each group. Ethics in psychological research. All of the experiments that get approved at universities and whatnot have to go through what they call IRBs, or institutional review boards. They look over proposed studies and judge it for its safety and consideration for the ethics for the participants in the study. Basic common ethical guidelines set forth by the American Psychological Association are: the rights and the well-being of the participants are the most important thing, and it must be weighed against the study's value to science. Participants must be allowed informed consent, so they can consent after they know all of the dangers and stuff. If deception is used, it must be justified, and participants may withdraw from a study at any time. Also, they must be protected from any risk or told explicitly of those risks. Afterwards, participants must be debriefed, telling what the true nature of the study was and the expectations of the results. Any person's data must remain confidential. So those are common ethical guidelines. And if for any reason a study results in undesirable consequences, the researcher is responsible for detecting and removing those consequences. So why would we use animals? Why would we use animals in psychological research? Well, we can kind of compare animals' conclusions to what we believe humans would do, and things that we can never investigate with human research. One thing that comes to mind is the studying of effects on orphans from their mothers. So if we remove monkeys from their mothers, we can study them, but we can never remove a human baby from their mother to study it and how it would result, what consequences there would be. Animals live much shorter lives, so it's easier to look at long-term effects. Scientists have more control over an animal's diet and basically the laboratory setting that it will be studied in, and they can be used for experiments after researchers conduct correlational studies with people. So if we know a correlation exists with people, we can try it out on animals first. Some people believe this is no more ethical than doing it with people, but it has helped us with find a lot of different cures for diseases and whatnot in research. And basically, animals only are used in about 7% of psychological studies, but there is an overall effort to reduce an animal subject's unnecessary pain or suffering. And that is all I have for you tonight. I know it was quite a bit, but if you have any questions over the learning targets, please let me know.